Our next speakers up are Jonny Johnson from Red Canary and Olaf Hartong from FalconForce. This next talk comes from two companies across the Atlantic from each other and pairs a multiple ATT&CKcon speaker and a first-time ATT&CKcon speaker. So as I mentioned in my talk earlier, and obviously from Lex's just now, data sources have been on our mind a lot this past year. We're often asked, what data sources should I gather? And we're interested in learning from Olaf and Jonny's experiences. So please welcome to the stage, Olaf and Jonny. Big green button.
Big one, all right. Hey everyone, welcome. So as Adam already introduced, we're going to be talking a little bit about data sources. I'm super excited about Alex's talk as well to see where MITRE is progressing. And I got the right button. So, okay, why do we care about data sources? I think it's an open question. Everybody has an opinion about it. So we'll talk a little bit about our opinion. We'll talk a little bit about how we start looking at them, what do we do with them. And of course, we need to have a conclusion for this. So that picture is already a slight teaser into one of the ways that we are looking at them. But first, let's introduce ourselves a little bit. So I'm joined with Jonny.
Hey everybody, my name is Jonny Johnson. I am a senior threat researcher at Red Canary. Previously, I was working at SpecterOps. My kind of focus is around Windows internals, a lot of database things, and I'm trying to, as the days go by, get better in reverse engineering. I am one of the hosts of the Detection Challenging Paradigms podcast, if you have heard of that. And probably the most important thing on this slide is I am a self-proclaimed professional at Call of Duty, specifically in 1v1 knives. So if you ever want to catch that, just let me know. So
nice. Right. My name is Olaf Hartong. I work at FalconForce, as Adam mentioned. It's a Dutch company, so you might not have seen it yet. And over there, I'm doing primarily detection engineering, general security research, try to build some open source tools to help people out. I started out as a documentary photographer, so I never went to school for this. And apparently you don't have to, right? Everybody can do as long as you're motivated enough. I have two young sons who I adore. And of course I like warm hogs since I'm Olaf. So, but moving on, I think this is one of our few memes, sadly. So why do we actually care about data sources? And the more data is sort of, conflicting message because we don't want everything. We only want useful stuff. So, couple of things for a value thing. So how do we value a data source? So one of the things is, well, we can at least determine where do we start looking, what do we need, which fields are actually useful for a good detection, and then primarily a behavioral detection and not necessarily a signature, if we can get that. But also from that perspective is what do we need in those fields to be there, and what is required to actually have that focus, and what events are also in terms of volume sort of valuable enough. I mean, we don't want to get a fire hose and then have one single potential event once a year. It's just not cost effective. And from that perspective also, how to help the IT people or whoever is onboarding this to get it enabled and get it into our data set. So this slide is probably almost as famous as Dave Bianco's that I've seen a couple of times already. And it's quite relevant, right? Even though most of our presentation is lists, it's just an easier way of presenting it. Looking at it from a graph perspective is super relevant. And to do that, so MITRE already has this great relational database of, for instance, a group that is tied to a tactic, then a technique. Everybody's seen this, right? So now the data components are there, and I skipped the data source bit because of the slide size. But it should be there. But from there, we need to go further because this is still nice as a defender, but how do we apply this? So one of the things that we can do now is, for instance, with the OSAM model from the Rodriguez brothers, that's now in the OTRF framework, so it's being applied by everybody. You can tie the events and even go to the provider stage. And later on, you can also do fields, these kind of things. It's really nice. And what you can do once you start doing this, you can add your detection rules. You can start maybe your detections or your sightings. You can do your attack scripts like the Red Canary guys put out, and much more. The possibilities are endless there. So what we can do later on is try to graph a little bit more. So where do we need to start looking actually if we start doing this? So there's a ton of data components in MITRE already. I didn't count them, but there's like, I think over 80. And these are the top 5 with references to techniques. So command execution is referenced in 253 techniques, which is a lot. And that list goes down. So this is important, but it's not maybe the most important, because there's of course more than a top 5. And sometimes an execution of a certain technique doesn't necessarily mean that it's in one of those. So never forget about those, because if we graph that, it's quite a lot already, right? It's almost a maze. And if you look back then into the events, which you can't really see yet, but you'll see in a bit, it starts to become more relevant. So, and in terms of relevance, how do we apply this? So one of the things that we looked at is Red Canary put out their threat detection report. So it's an oversight of what they've observed over the past year. And these are the top 5 most observed techniques used by attackers in their client base. And from there, we can start mapping that to the data components. So the data components are the yellow bits, the techniques were on the left, and then we can start plotting that into which events would we need to actually detect this. And this is, of course, arbitrary. It's built by the open source community and MITRE, so it's never complete, but it might give you a good starting point into say, okay, hey, I have, I don't know, Windows event logs and these event IDs I have. Let's start looking into that data set to see if we can actually build detections. So if we start looking at which of the components were listed in those techniques and then put that next to the top 5, there is overlap, so that's cool. But there's also other stuff, right? So from there, we can say, okay, maybe some of the other data sources are as important or more important than those top 5. And one of the things that we want to take you into now is basically 2 examples. So I'll start with the Windows registry, and then Jonny takes over and he'll show another data source that we find very valuable. And why did I select the registry? Well, it's probably one of the most valuable data sources for a forensic investigator. They love that stuff. I did a lot of IR, and this is the first place I usually go. But for some reason, defenders look at it less, in my experience at least, where if I come to customers, they usually do process command line, process creation, these kind of things. Super nice, very valuable, but easier to avoid. Whereas the registry is very hard to not have a registry key registered for an action that you take. So from that perspective, behaviorally, this is a great focus area. And if we start looking at the amount of techniques that actually are referenced with a registry key, either components, so it can be modification, creation, anything like that, there's 86 of them. So it's quite a lot of techniques that we can catch from that. And I didn't do the proper research yet, but I think there's way more techniques that we potentially could cover with it. Just it's not tagged yet, right? So it's not a MITRE's fault or a text fault. It's just somebody didn't write it up. And from there, there's like leagues of examples, but a couple of those are COM hijacking, all kinds of discovery stuff. And these are probably the hardest to do from a registry perspective because the telemetry is not always there, as I'll show you later. But you can even add a user to the registry, for instance, or create a service, and it's all visible there. So from that enumeration perspective, as I mentioned, so there's all kinds of registry keys that attackers will look at to see, hey, how well secured is this box, what kind of policies are there. Even if you look into the code of seatbelt, there's all kinds of services and other locations where they're looking to see, hey, what can we do, what is exploitable, what is something that we can do. And from a more practical perspective, so a service creation you can just do from a PowerShell command, for instance, or do it through a GUI. And what will happen, of course, is if you do it the proper way, you'll get a service creation log entry in the Windows event log. However, you don't have to do that. So one of the things that you can do is just write these keys to the registry. And I just did this with Procmount, but you can monitor in all kinds of ways. I really love Procmount because it will give you the full details. And this is something that I can then take and replicate and see, hey, if I only write those registry keys, is that service still there? Well, actually, it turns out it is. So and then that event ID that we saw before doesn't get generated. So if I'm looking only for service creation event IDs, I might miss it. So this is a better detection. Because if you do it the proper way, you get it. If you don't do it the proper way, you still get it. And then from there, in this registry, you can basically get everything. So you can get service type. So maybe you don't want to have an alert for every new service creation, which kind of makes sense. But maybe you do want to know when they start a kernel driver or something like that. And you can also see how it started. So if it's automatically started or manually, these kind of things, which might influence your decision tree later on. And you also get the binary that's tied to it, the name, and so forth. So it's quite valuable just from one single data source. And the same can be done actually by adding a user via the registry to the SAM database. So if you add a user via the normal GUI, you will get all kinds of event IDs, event data, and the SAM hive will also be updated, and you can query it from the registry. But you can also do it the other way around with some fiddling. So I found a tool that did it. I don't know exactly how it works, but it's quite nice because it adds the registry key and then the SAM database is also updated. So this is another way of covertly adding a user to a box that you might otherwise not catch. And again, all kinds of telemetry is being generated, so we can just build a detection based on certain traits of what is actually happening in this set. So how do you get that data? That's then primarily the biggest concern, right? So Windows has a feature to do this. However, it's not very accessible, not very easy. You have to basically create a secure a SACL basically on an object, and you have to define it per registry key or per path that you want to be monitoring. But the awesome thing is that you can also do it for read access. So if they start enumerating certain keys that you're actually interested in, you can build a SACL for only those and do the rest from another path. Like Sysmon is awesome for it, of course. But most of the EDRs also have quite good visibility in creation, deletion, modification, but not necessarily into reads. I haven't seen a lot of EDRs that do that. Please do, by the way. Just for a couple of keys, right? I don't want everything because then you get that fire hose that I talked about in the beginning. But it would be really valuable to have some of that telemetry there. And while researching, you can of course look at the event tracing for Windows. There's a specific provider for that. Again, you don't want to ingest that into your SIM because then you get flooded and poor. Or you can use a tool like Procmon, OS Query, something like that. Maybe even Velociraptor. And if you start graphing that again to that similar thing, you can see that also in attack there's quite a lot for the modification, not a lot for the reads, which makes sense. It's harder to detect, still would be valuable. And then again, this is also a biased look because this only looks at like Sysmon, Defender for Endpoint, and the Microsoft native logs. So I would encourage other people to start augmenting this as well. It's all open source. And the tool to generate this will be published as well. So my colleague is writing a PowerShell script to make a nice ingestion method into Neo4j. And I'm building a Bloodhound port that actually gives you all the secondary attributes as well. So I'll now hand over to Jonny for his subject.
Thanks so much. It's this button, right?
Yeah.
Okay, great. Yeah, so now we're going to move into process access. I don't see a lot of this used, at least by Defender. So I really want to talk about the importance of this SubData source. So let's get into it. So the objectives for this section is to talk about what is process access. I want to take a step back and just go ahead and speak about what is a process, what are objects, what is a handle, and then what is the access that the handle might return to you. And then most importantly, how can a Defender use this in the day-to-day telemetry? I don't know why I chose that. I just saw it on the internet and I was like, you know what? I think this is a good place to display that. So if you're not familiar, process access is a sub-data source within a broader data source known as process. Within process, you can see OS, operating system API execution, process access, process creation, and process metadata. Wanted to focus on this just because there is a little bit of a niche piece as it is relates to attacks. And thanks to Olaf for making this mapping for me. There are multiple attacks this relates to. There probably is more than what is listed here. Just research hasn't been done on that quite yet. And there are a lot of good like events that provide that to us, right? So let's talk on some of those. If you're not familiar, sysmon will give us this, an event ID 10. There are some great attributes in here that I will go over in a moment, but another one is actually given to us by the Windows security event, and this is 4656 as well. This one's a little bit more unique, as I'll touch on this in a moment, but it actually will give insight into other object accesses as well, not just process-based. Great. So let's take a step back and let's talk about all these different pieces. So what is a process? Think of a process really as just a container that that hosts a whole bunch of resources to run an instance of a program. So really, like inside of a process, you'll have threads, you'll have memory, you'll have tokens. And that is, the process is meant to contain all those things. It is backed by a structure within the kernel called the eProcess structure, and that'll be important here in a moment. And it is a process type kernel object. Also important here in a moment. Objects. These are just data structures that need to be shared and protected and reflect some resource, right? So a thread is an object, a process is an object, a token is an object. These are all different types, the registry as well. And anytime you want to access an object and do something with that target object, you have to obtain something called a handle if you are in user mode. In kernel mode, you can do a pointer or you could have a handle, but specifically within user mode, you have to have a handle. So what does that look like and what's the purpose of this? A handle allows objects to be shared across processes. This is simply just an entry within an internal table, and it's used to regulate access to that target object. Once the handle is obtained to that target object, dependent on the access that was granted, the source user can do whatever access that is, and I'll get to that in a moment. They just can't do anything higher than what they requested. So what is access? Each object type has a set of access rights that allow the requester to perform a set of actions. So an access right is simply just a bit flag that relates to the different type of accesses you might have on an object. And then there's something called an access mask. And the access mask really just defines what users and groups have access to that target object. And so let's look at a practical example of this. So there's an API out there called Open Process. So say I want to access a target object, specifically a process, since this is process access. The first parameter that's passed through is called desired access. And at the bottom, it actually gives good documentation that this is just the access right to check the security descriptor of that process to see if that user has access to do that operation. So like I mentioned, every object has these access rights, these that will specify the operation that you want to perform with this object. This is just a small screenshot. There's a whole bunch of them within Microsoft documentation, so definitely suggest checking those out. This is just a small screenshot of the process one. And because Olaf talked about the registry, I wanted to show that there are instances of this with the registry as well. But we'll move forward just talking specifically about processes, since the SubData source today we're worried about is process access. So back to sysmon event ID 10. There's a lot of really cool fields in here. Obviously, there's the source image, there is the source thread, there's the source process. There's also the target image, the target process. But most importantly, one thing I want to get into is the granted access field. How many people here have like seen this and probably have seen like 0x1 FFF as it goes with mini malware or anything like that, right? Great, cool. Let's get into that. Whenever a process wants to implement some function, we're going to use mini dump write dump here on another process. The reason why I chose this was for two reasons. One, dumping LSASS is pretty popular, and two, it seems like every week there's another technique or way to dump LSASS. So figure this would be interesting to some. Whenever this happens, we need to identify the function, the API that's being done. So this is a screenshot of mini dump write dump, and the first parameter being passed through is a handle. Great, now we know that it needs a handle and it has to specify those rights. But the question is, what rights do I need in order to dump LSASS with this particular API? Well, within that first parameter, it actually specifies that you need process query information, process VM read whenever doing this. Great, so now I know that is the minimum rights an attacker needs to leverage this API. Once that's identified, I'm going to figure out what those relate to. And this is just the hex representation of what those accesses look like. And it's going to be 1410. So this is the minimum, again, that an attacker needs to do to dump LSASS via mini dump write dump. They could grant higher, but not less. So essentially, you could do like 0 times 1FF, as many people have seen. And that's simply because people are just like, give me all the rights and I'll do with this as I please once I get that handle. So we're going to get into Bitrise Operations. If you haven't heard of these, there's AND or XAND, but we only are going to care about AND today, so I'm not going to speak about the rest. And this can be used with Sysmon's Event ID 10 granted access. It can be used any event source that gives us that granted access, right? And specifically, whenever this is done, we're going to see the binary representation of these access masks, and then we're just going to go down the line, and we're going to see if both of those are 1, then that's a match, and we're going to return 1. And essentially, what we want to do with this is see with whatever access that was granted, if the access right, that the minimum that the attacker needs lives within that access mask. Just because a number looks higher than what an attacker needs doesn't mean it actually lives inside that. So say we have a normal, let's say proc dump does all access, it dumps it, and it's going to use mini dump write dump. It does use that API. Does 1410 live within all access? So this is kind of what the math will look like. I'm not going to get into it too much, but again, we're looking for matches of 1s. If those line up, then we will see when those correlate. Answer that question is yes. 1410 does live within 0 times 1FF. But what is the, how can we figure these out as defenders, and how can we leverage this? I think that's the big piece, right? What's the impact? This is very easy to do inside of PowerShell, but there are actually some analytical platforms that allow you to do these operations as well. Jupyter, if you're, I don't know if anybody's a Jupyter Notebook fan here. I very much am one. It definitely allows you to do that. And then Kusto as well will allow you to do this. So let's look at examples, because if it's not practical, there is a threshold of research and practicality. So let's look at the practicality of these. Dumping LSAS. So let's look at that mini dump write dump API. Here we can see a query. This is a detection that I wrote in my lab, and essentially is just going to use Event ID 10 as the main data source for this detection. Keep in mind, if you do this, this is going to be very loud. Event ID 10 is very loud, as when processes are accessed, that happens all the time in the environment. And if you allow this event ID to go through, it's just going to be super noisy. So that being said, let's look at an example of when it's like the secondary event ID or the sub data source within that. And this is another example with read process memory, but I want to get into the sub data piece one. So process injection, everybody loves process injection. Reflective DLL injection. So this is specifically, in this instance, someone's using create remote thread API. And so here I'm using Event ID 8 from Sysmon, but I'm actually leveraging the Event ID 10 to tell me, like, hey, was create remote thread used whenever whenever these events fired off? And then if so, what processes were those, and what were the access rights that were actually given to the defender? Wrapping up, so again, remember, as defenders, we have to look at the bigger picture, and we have to understand our telemetry sources and understand really how we can leverage them to their full capacity. And we have to understand within our organization as well, what fits, what makes sense, what data sources really do we need in order to catch the things that we want. And then, again, understanding the telemetry is the key to unlocking the true potential. There are a lot of really good open source projects that actually go into some of these things. The OSIM project, Sysmon Modular by Olaf, that goes through these. But that is the end. Thank you.
Oh, I don't want to cramp your, blow up your spot here. Yeah, I'll sneak in the middle. Why not?
Yeah, there we go.
Yeah, I love this. I feel like there's a data component for this, a process modification or something.
Yep.
Yeah, great conversation, great talk. I think we have time for a couple questions, but I really love, kind of the theme of your talk was it's not arbitrary. You don't, just like Haley said earlier, you don't start in the top left of the matrix and work your way through and try to detect everything. And I love kind of what you captured in terms of, how do you start making those decisions? It's a little bit knowing yourself. It's a little bit knowing your adversary. It's a little bit knowing, like you said, the impact. For those out there that, this really, maybe it was the first time they really saw deep in the weeds for detection engineering, what kind of advice would you give? Because I, very often, myself included, and Lex has been there, we pick up on a topic, we get in the weeds, we're like down at access flags and things like that. And it's like, how do you bring that back out? And like you said, how do you show that back out to the organization and, provide the value and kind of bake that into threat modeling and all the other processes that are, compounded in this decision?
Yeah, I would say the first thing I could say to that is don't be scared. The biggest thing to remember as we continue as researchers is we're not going to know it all. And the deeper we go into something, we might have unraveled a bias or something we didn't know prior. And that's phenomenal, right? But in order for that impact to be there, there needs to be either some type of scalability potential or some type of output to our teams. And so when going into some of these things, the question might be like, is it practical? Like if someone doesn't have Jupyter Notebooks or Kusto or have the analytic platform to do some of those access flag operations, the bitmax operations, it might not be realistic from the type of detection engineering. They might have to look for specific ones, but the point is to bring awareness in general around those behavioral opportunities for our environment.
Excellent. Yeah, I love that comment because it's not having at the end of a good question, you don't need to have the answer. It's just the knowledge. And like you said, even if you know your gaps and you know your limitations, that in itself is more powerful than not being, like you said, being afraid of really digging and answering those tough questions.
Absolutely.
We have about maybe time for 2 questions. I see a couple hands popping up. Anyone brave enough? While we give people a moment, I know Olaf, we've spoke about this in the past. I know you come from a very artistic, visual background. What would you share in terms of the benefits that you've experienced? Really making really complex ideas more tangible. Like what is kind of the thought process that goes into that?
Yeah, personally for me, it's just easier if I see it, right? So having all these Excel sheets is great because you can automatically search through it. But in a graph database, you can do the same, but I can visualize it for myself. And it's so much quicker if you saw one of those graphs, you can immediately see, okay, I need this, this, and that.
Yeah.
Whereas that mental reference might be there somewhere, but if I can visualize it for myself, it's so much quicker. And then I can also flip it around. So what I recently did is add all the components to our detections and basically start looking at, hey, the detections that I wrote, are they actually the same as MITRE referenced? So I can see in the case of some detections that I use a data source or a specific event ID that isn't referenced or the other way around. And then I can either improve my detection or I can submit something to you guys and see if it would fit. So these kind of things are very difficult to do for me, at least, not having it in a graphical way. It's just a quicker way for me to digest it.
I think I'm in the same boat, so I very much appreciate all the work you do in that space to really, like said, kind of not just to being different, but also just being more inclusive of the different types of personalities. Because I myself, I will read something, if you put a picture next to it, I'm going to remember the picture, not the
Same.
all the words are really fun. But I think we're coming up on time here. But one final question I wanted to have, kind of ask you both was, going forward, what can we as the attack team do to, like I said, one of our biggest goals with this data sources and data components was bridging the gap between, as Lex said earlier, kind of the abstract and the universal down to the, what are the real practitioners doing day to day? What problems do they see? Any suggestions for us, the attack team, as well as the community? What can we do better?
I would say the biggest thing that I would see is there's a lot of correlation going from the data source up to like the technique, but maybe spreading the data sources or the sub-data sources to relevant event IDs that we see commonly within the community. So like SysMon security events, MDE, things like that. That might be very beneficial to people. And then maybe have some type of repository for those tables that might exist.
Make it real. I love that.
Yeah, I think we discussed this earlier as well, we private, but I think having a classifier or a weighting system to the event ID or at least to the component. So which component is the most likely to give you the best detection? And of course, sometimes you need to correlate and do multiples. I think that will be useful for a lot of people to start. I mean, if you get all the techniques that you have to build, like Haley described, where, right? Like so having that direction and maybe in the high level description from that same detection perspective, give a couple of pointers. What is like guidance? You don't have to give the rules, I think, but steering people in the right direction would already benefit a lot of people.
I love that, and it goes back to not being scared, or even if we can't answer the question, let's ask it, and
absolutely,
a step in the right direction is a step forward. Well, thank you both, and
thank you.
Yeah, thank you.